Alright, now we're going to talk about finding distance and midpoint on a coordinate plane, which is a two-dimensional. The textbook definition for distance formula between 2 points on a coordinate plane will tell you that the distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay? For midpoint, it'll be a coordinate so it's going to be in parentheses, and it'll be x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2, and close parentheses. So when we're in two-dimensional, so it's going to be double the work. What we do to x, we have to do to y in order to handle these types of situations. Just FYI. There's really not nice, neat ways of handling these types of formulas. I'm sorry, like it was earlier. The first example wants us to determine the distance between A and B, given that point A is located at -4, 5, and point B is located at 2, -3. So the first thing we're going to have to do is make sure we plot these points correctly. So -4, 5 would be to the right, I'm sorry, to the left, 1, 2, 3, 4, and up 5, 1, 2, 3, 4, 5. So point A would be here. Point B is to the right, 2, 1, 2, down 3, 1, 2, 3. It might help you to label on the graph itself. So this is -4, 5, and this is 2, -3. So we're looking for the distance from point to point, and it might help you to draw that line so you get that visual. So it's not as simple as simply counting anymore. We got to use the distance formula. Again, the distance formula. So we would say AB is equal to x2 minus x1 squared plus y2 minus y1. Sorry, there's a little delay in my writing here for some reason. I have no control over that. And y1, oh Lord, my computer's doing what it wants to do. Uh-oh, stop. Oh my goodness. Let me try and pause. We'll be back. Alright, sorry for that delay. So what you want to do first is label your x1, y1. So let's say this is x1, y1. This is x2, y2. So now we can substitute them where they belong. Again, put the things that have to be there every single time. So I'm going to put my parentheses with my minus in between and my square on both sides. Those are things that have to be there every single time, no matter what. And now I'm going to substitute the values. So x2 is 2, x1 is -4, y2 is -3, and y1 is 5. So what I would do here, yes, you can put all of this in the calculator in one step. You just have to be very careful to make sure you insert all the correct amount of parentheses. But I want to do it to make sure I get the right answer, so I'm going to do it in stages. So bear with me. The first stage is to combine the like terms in the parentheses. So in the first set, it says 2 minus negative 4. We talked about double negatives already. So that's 2 plus 4, which is 6. And that's something that your calculator can easily handle. 2 minus negative 4. And the calculator should tell you it's positive 6. On the second set of parentheses, it says negative 3 minus 5. So this isn't a double negative scenario. You're actually going to take negative 3 and subtract 5, and you would get negative 8. So now, leaving the square root sign, leaving your plus sign, the next stage would be actually to calculate what 6 squared is. And I don't know if you recall, but if you're squaring something or raising it to the power of 2, you're multiplying it by itself twice. So 6 times 6, in other words, is 6 squared, which is 36. For negative 8 squared, you would be taking negative 8 times negative 8, and that would give you a positive 64. Because negative times negative is positive. And now the next stage, leaving the root still, we haven't used it yet. You're going to add 36 with 64, and you get 100. So the final stage is to take the square root of 100, which would end up being 10. And that is something I would definitely grab my calculator for if you don't understand how square roots work. But the distance from A to B is 10. So we've done what was asked of us so far. And that's how you would use the distance formula. Again, you can type it in your calculator all in one motion using this equation here. I just recommend being very careful, and if you don't have the same amount of parentheses that I do, you will not get the correct answer. So just be very careful. If I have time later, I'll demonstrate it in the calculator on here. Well, let me just do it right now for you, just so you can see if you have a calculator and you're practicing at home. But if I do second x squared, there's the square root sign. Then I have to open a set of parentheses and type 2 minus, open a set of parentheses, negative 4, close that parentheses and close the main parentheses. And then I have to square it by hitting x squared, like that. Then I hit my plus sign and open up a new set of parentheses. And I need to type negative 3 minus 5, close parentheses, and square that. And that's the proper way you would do it. Hit enter, and you get 10. Okay, so I'm not saying you can't use calculator. I was just saying make sure you're very careful on your parentheses when you do, if you want to ensure yourself that you have the correct final answer. The calculator is your friend, but if you don't use it properly, you're not going to get the right results. So the next thing I have to do is find the midpoint. So the midpoint from A to B is going to equal, again, it's a coordinate, x1 plus x2 over 2, y1 plus y2 over 2. That's the formula for midpoint. So, using the same x1s and x2, that would give me a negative 4 plus positive 2 for the bottom, for the x's. For the y's, y1 is 5, y2 is negative 3. So now, again, just like with the other midpoint, you got to take care of the top first. So it would be a negative 4 plus 2, which would give us a negative 2 for the first part of the coordinate. And the second part says 5 plus negative 3, which would give us a positive 2 over 2. And then you would take negative 2 divided by positive 2, you get a negative 1. Positive 2 by positive 2 is a positive 1. So the midpoint is negative 1, 1. And it's also asked for us to plot the midpoint, so let's do that. So negative 1, positive 1 is right here. There's your midpoint. And that's how the distance and midpoint formula work. So now we're going to determine the distance between Nimitz and Taco Bell and plot the halfway point. So T is plotted for us, but we don't know its coordinates, so let's write those first. We went over to the left 1, 2, 3, 4, 5 times. So x is negative 5. And we went up 1, 2, 3. Oh, I'm sorry. 1, 2, 3, 4, 5, 6, 7. So it's negative 5, 7 is the coordinate. And for n, it's over 1, 2, 3, 4, 5, up 2. So positive 5, positive 2. Again, we're finding the distance between t and n. We would use the distance formula again, but I have another method to my madness that might be helpful. What you can do is form a right triangle by coming straight down and straight across. Sorry, that's not as straight as I would love it to be. Now, if you form the right triangle, this is another process that you could use to find the distance. Count the side on the right here. It's 1, 2, 3, 4, 5. So this would be 5. And count across. It'd be 1, 2, 3, 4, 5, 6, 7, 8, 9. It should be 10. It should be 10. Again, it works best if you're not on a computer and you can see and read the grid a little better. But it's 10. So to find the distance using this method, you would say use the Pythagorean's theorem. Do you remember Pythagorean's theorem? Well, here's the shortcut. You still have to have the square root symbol, but you're going to take 5 squared plus 10 squared. So essentially it's the same thing going on that we did before, but it's a little bit more condensed and sometimes easier to understand. So on this one, I'm still going to do it in stages. 5 squared is 5 times 5, or 25. 10 squared is 10 times 10, or 100. So now the next stage would be the square root of 125. Now let's grab our calculator and see what the square root of 125 is going to give us. Again, the square root is second x squared and type 125. It gives us a decimal, The reason it gives us a decimal is because 125 is not a perfect square. And so it's approximately 11.18. If it was a test or a quiz, I would allow you to leave the answer as the square root of 125. I might even prefer it. So this is a good answer. But you might also want to check the calculator to see that you did it right. So 11 point, what did I say? 118 is another good answer, but this is an approximated answer because it was a decimal, so it's not going to be exact. All right, so that's how you can find the distance, another method. And it seems, again, a little simpler. Find the midpoint, same way. Sorry, no shortcut for that. So again, it's x plus x divided by 2, y plus y divided by 2. And, well, I kind of made it a little simpler when I wrote the formula because I didn't do my x1s and so on and so forth because those don't really matter. All right, so the plus and the fraction will matter, but the x's, it doesn't matter the order, not at all. So as long as you just put them where they belong, x with x, y with y. So one of the x's is -5, the other one is +5. One of the y's is 7, the other one is +2. There we go. Now still do it in stages. -5 plus 5 is 0. 7 plus 2 is 9. We know that already that 0 divided by anything is 0. And 9 divided by 2 is going to give you a decimal, 4.5, or you can keep it a fraction. But since I have to graph, 4.5 works best. So let's plot it up here. So 0 and then go up 4.5. So 1, 2, 3, 4.5 is about right here. There's your midpoint. On this one, it says Q is the midpoint of segment PR. And you might notice on the graph, we don't see point R. So again, we're going to have some segment PR. Sorry, I meant to do it in reverse, but it doesn't really matter. Where Q is in the middle. So there we go. If we know the distance from Q to P, we'll know the distance from Q to R because it'll be the same, right? We talked about what midpoint means. So this is what we're going to do in this scenario. We're going to use a method called EME. Endpoint, midpoint, endpoint. P and R are your E's, and Q is your midpoint. So watch what I do. First, I need to know the coordinates from P and Q. So P, I went over to the right 2 and up 1, 2, 3, 4, 5. So it's 2, 5. For Q, you went left 2, up 2. So this is -2, +2. So we're going to put our E and our M coordinates. For P, we have 2, 5 again. For our midpoint, we have -2, 2. So we're looking again for our other endpoint, R. So let's see. To get from 2 to -2, what did we have to do? We had to add, or sorry, subtract 4. You had to subtract 4. To get from 5 to 2, we had to subtract 3. So keeping that the same, since we have the midpoint, we're going to have to subtract 4 for our x value for r, and subtract 3 for our y value to get y. So with that being said, let's have my parentheses ready to go. Negative 2 minus 4, sorry, negative 2 minus 4 would equal negative 6. So that's going to be our x value. And then 2 minus 3 would give us negative 1. So that's our y value. So r is located at negative 6, negative 1. And we got fractional distance on the number line as well. I mean, on the coordinate plane as well. Just like for the number line, there was 3 steps. Well, on the coordinate plane, it's 6 steps, but it's the same 3 steps, but twice. You got to do it for x first and then do it for y. So now what we're going to do is find the x coordinate first. So find x. First step, find the distance between your x values. So from x to x, we have our absolute value sign and our minus sign that are standard. Again, you want to put the x on the right first. So the x on the right would be positive 2, and on the left is negative 3. So it will be absolute value of 2 plus 3, which is the absolute value of 5, so 5. That's the distance between your x's, 5. Then the second step again is to find the fractional distance. So you're going to take the 1 over 4 times the 5. Which will give you 5 over 4. Which is equal to 1.25. And now, step 3, you're starting from n, so you're going to take n and add 1.25. So n was x value was negative 3 plus 1.25, and that would give us negative 1.75, I'm pretty sure. Or as a fraction, a negative. Mm, hmm, I'm stumped for a second. I'll come back to you on that. So this negative 1.75 is your new x value. So now we got to find y using the same steps. First, find the distance from y to y. Have your absolute value and your minus. One of your y's is at positive 3, and it's on the right, and the other one's at negative 3. So that would give us absolute of 3 plus 3, or absolute of 6, which is 6. Then find your fractional distance. So it's 1 over 4 times 6, which would give you 6 over 4, which reduces to 3 over 2, which is 1.5. And now we're going to do step 3, starting at n again, n's y, and we're going to add 1.5 this time. So n's y is negative 3 also, plus 1.5 is going to equal negative 1.5. So this is the y value. So the final step is just write it as a coordinate. Put your x piece and your y piece together. So point R is going to be located at negative 1.75, comma, negative 1.5. If I were to plot that on here, negative 1.75 would be about here, and negative 1.5 would be about here. So point R would be here, which makes sense. It's 1/4 of the distance. It's not the midpoint. Midpoint would be right dab in the middle. This is only a quarter of the way. So that's how fractional distance works. I apologize for the long lesson, but it's easier explained, I'm sorry, in person than it is using the computer and having to switch screens. But this concludes your notes. They'll pick up